Solving systems of equations with Desmos is pretty straightforward, but things do become a little bit more challenging if we're only given a word problem rather than being given the equations explicitly. In example 4, for instance, we're told the perimeter of a rectangular floor is 80 feet. We want to find the dimensions of the floor if the length is 3 times the width. So what we need to identify are the statements that we want to translate into equations, and then we can take these one at a time. So if the perimeter of a rectangular floor is 80 feet, that means 80 would have to be equal to 2 times the length plus 2 times the width, where we'll let x equal the length and y equal the width. The other statement we have is that the length is 3 times the width. So we could translate that into the equation. X is equal to 3 times the width, which is y. Now we have our system of equations, which we can plug into Desmos. And then again, change our viewing window until we can see that point of intersection between our two lines, which in this case occurs at 30, 10. So our point of intersection occurs at x equals 30, y equals 10, meaning that our solution would be a length equal to 30 and a width equal to 10. In example 5, we have a lot more going on. We have a store that sells cashews for $6 a pound and peanuts for $2.50 per pound. The manager decides to mix 80 pounds of peanuts with some cashews and sell the mixture for $4 a pound. How many pounds of cashews should be mixed with the peanuts so that the mixture will produce the same revenue as with selling the nuts separately? So what we know is that a new mixture is going to be made by taking 80 pounds of peanuts and mixing that with some amount of cashews. So we'll let x equal pounds of cashews. And the other thing that we don't know is how much of that mixture they'll make. So y would equal the number of pounds of that new mix. So this first equation relates the number of pounds of each product going in to that mix, to the total mix. What we need is a second equation that relates price. So if we can sell this new mixture for $4, that would be $4 times every pound of it. We want to know when that would be equal to selling the same amount individually. So that would be selling our 80 pounds of peanuts for $2.50, plus selling however many pounds of cashews for $6 a pound. Once we have our two equations, again, we can come back to Desmos. And then scroll to find those points, or find that point of intersection, which in this case looks like it's happening at 60, 140. So what that tells us is that if our value for x is 60, we would want to mix in 60 pounds of cashews, which would give us a total mix of, let's see what that was, 140 pounds. So he would make 140 pounds of that new mixture by combining 60 pounds of cashews with 80 pounds of peanuts. In example 6, we have a doctor's prescription that calls for a daily intake of 60 milligrams of vitamin C and 40 milligrams of vitamin D, you have access to two compounds, one that contains 50% vitamin C and 50% vitamin D, the other with 40% vitamin C and 20% vitamin D. We want to know how many milligrams should be mixed to fill that prescription. So if we start off by thinking about how much vitamin C we're prescribed to take, we know we need a total of 60 milligrams of vitamin C, and we can get that by taking that 50% mixture and including some number of milligrams of that mix. And we have the second mixture, which has 40% vitamin C, and we're going to use some amount of that mixture. So X here would represent the first mixture, Y that second mixture. And then we need 40 milligrams of vitamin D, where we have 0.5 times X, the 50% that's contained in that first mixture, plus the 20% that's contained in that second, not mixture, but compound. So this gives us our two equations to consider. And in this case, we don't have to scroll. To find that point of intersection would be at 40, 100, meaning we would want to use 40 milligrams of that first mixture, or I'm sorry, that first compound. And we would want to use 100 milligrams of the second compound.